Hello, everyone. This is ESTR 2020's presentation. Our topic is Bayesian and classical statistic comparison. My name is Wenhao, and my group mate is Haoyuan. So let's move to our contents of the presentation. In this presentation, first I will give an introduction about the basic difference between the Bayesian and the classical statistic. And then I will use very interesting topics to illustrate the pros and cons of the different two methods. And following that, I will talk about the difference in estimation and the hypothesis testing in both two statistic methods perspective. And then my groupmate Haoyuan will talk about a case study in some potential applied field and give a summary. So let's move to the first part, the introduction. The first question is, what does the probability means? In classical and Bayesian probabilities, they have different understanding. In classical, the probability represents the frequency. Let's consider the coin tossing problem. If we toss a coin many times, we will observe the result. The frequency of head is very close to the frequency of the tail. And at this time, we can say the probability of the head is equals to the probability of the tail. So in this case, the probability means the frequency, and it's a very object things. But there is not all the tests is like cross toying, we can repeat it for many times. There exist many tests that we can't repeat many times. The weather prediction is an example. We can't predict, we can do many tests for the tomorrow's weather. For example, if the observatory says that tomorrow will be rainy, the probability is very high. But we can't take many tests for the tomorrow because tomorrow is only once. So it reveals there is another understanding way of the probability. It can be just represents the frequency. Actually, in Bayesian's views, the probability represents the strength of the evidence, attitude, or a belief. That is to say, when we say the probability of the rain is high, that is to say we have many data and evidence to say that we have highly likelihood to believe that tomorrow will rain. That is the idea behind Bayesian statistics. So from that interpretation, what do we need for these two methods? For classical, we need the model. For the coin toss problem is simple because it just have two possibilities. One is the head and the other is the tail. But how about if we want to investigate the average height of a school? We need to model that. For example, we think the height will be in normal distribution. And the classical statistic is based on objective frequency and inferred from data. We need to notice that our choice about the model will largely influence the result we get. If we choose the model as a linear model, maybe the result will be completely wrong. And as for Bayesian, it also needs a model. But besides that, we need a prior information, just like the weather prediction. We assume the probability of rain before we get that data. So it is about the subjective beliefs. What about the pros and cons of these two methods? The Bayesian statistic is flexible and intuitive, but it's sensitive to a prior probability. As for classical statistics, it's not performed well in small data, but sensitive to model, as we elaborated before. If we choose a very poor prior probability, the Bayesian statistic may give a wrong result. But if we choose the wrong model for classical statistics, it also gives a wrong result. We need to note that both for Bayesian and classical statistics, they will be important to select objective data. If we select data just by our preference, the result will be very subjective. Here is a very interesting example about does the God exist? There is a philosophy gives the reasoning using the Bayesian statistic. It's first he said the prior belief as the 50% that God exists. And then he considered several factors. And finally, every factors corrected the belief. And the final result is the 67%. How about if we use the classical statistic? We will set the null hypothesis as 0 and the alternative hypothesis as 1, and then assign significance level, and then we do a lot of tests. We can see that in Bayesian statistic, we only need to consider several factors because we already have the prior belief. But for the classical, we don't, so we may need more data. But on the other hand, the Bayesian statistic, the result will be largely influenced by the prior belief if our data is very, very little. So that is the pros and cons of Bayesian and classical in one view. And let's talk about the difference in estimation. The likelihood function p, x, theta are both recognized in Bayesian and classic. Bayesian treats the model's parameter as a random variable. You can imagine it a probability density function. And in classical, it treats the parameter as fixed quantities. It's just a value. There will be a value that can make the likelihood function the max. That is to say, this is very likely. So this value of theta is more convincing than other value of theta. That is what we call maximum likelihood estimation. And if there is no prior information, the MLE will be same as the maximum post probability in classical statistics. So besides that, we will know the Bayesian can utilize the information to achieve better estimation with reasonable prior information. So that's very important. And then we talk about the difference in hypothesis testing. The classical statistic is not calculate the probability of the H0 and H1. It's just to say if H0 is true, we will have a distribution of the different results. And then we observe the result. If the observation is a very small probability event occurred, that means it's unlikely to do that. So we reject the original hypothesis as 0. Note that there are some parameters we need to choose, but things are different in Bayesian statistics. The Bayesian directly calculates the H0 and H1 and compare the probability under the assumption of theta. So we can see that the patients can maybe have some advantages in multiple testing problem. For example, if we want to test which product is better in product 1 and product 2, if we use the classical, we need to compare many times. But if we use the patient statistic, we can set the value for theta for different H0, H1, H2. H1 means product 1 is better than 2, and H2 means opposite. So H0 means they are the same. So we only calculate the H0, H1, and H2 3 times and compare, we can get the result. But for classical, it can only compare 2. So we may need more times to compare it, and we will need to multiple time tests.